Hello, my name's Gabe. For this problem, we're asked to use the divergence theorem to find the integral of the dot product of f with n, where f is given to us as x squared I plus y squared j plus z squared k, and then we're asked to find the outward flux of I through the surface given by S. So in order to perform this integral, what we want to do is we want to use the divergence theorem. Now this here is a consequence of the divergence theorem, which we're going to use. So instead of integrating, or instead of finding this surface integral, we're going to instead find this triple integral of the divergence of f over some solid q, which comes from our surface S. So let's get started by first finding the divergence of f. So looking at f, we'll see the divergence of f is 2x plus 2y plus 2z. So now, if we're looking for our integral, we can instead write this as a triple integral over q, and this divergence of f, well, we already found that that's equal to 2x plus 2y plus 2z. So now we're going to take this idea and we're actually going to find this integral. So if you imagine the surface bounded by x equals 0, x equals a, y equals 0, y equals a, and z equals 0, and z equals a, well, we want to imagine that this surface, we have x varying from 0 to a, y varying from 0 to a, and z varying from 0 to a. So our limits of integration for both x, y, and z should be from 0 to a. And we also found that our divergence is 2x plus 2y plus 2z. I guess I'm coming up here, and that's equal to that. And it really doesn't matter which order we integrate in. So let's integrate with respect to z first, y second, and x third. So integrating with respect to z first, we'll have the integral from 0 to a of the integral from 0 to a of 2xz plus 2yz plus z squared. And we're going to evaluate this from z equals 0 to z equals a. And then we still need to integrate with respect to y, so we have dy, and we have to integrate with respect to x. All right, so what we see here is that if we substitute in z equals a, we'll have 2xa plus 2ya plus a squared, and if we substitute 0, well, this term becomes 0, this term becomes 0, and this term becomes 0. So this is equal to the integral from 0 to a of the integral from 0 to a of 2xa plus 2ya plus a squared. And now we're going to want to integrate with respect to y, and after we do that, we'll integrate with respect to x. So let's go ahead and let's integrate with respect to y. So this is going to be the integral from 0 to a, and if we're integrating everything with respect to y, we'll have 2x times a times y plus, here we'll have a y squared a And here we'll have an a squared times y. Now we'll want to evaluate this from y equals 0 to y equals a. And finally, we'll integrate with respect to x. So here we also see that if we substitute y equals a in, we'll have 2 times x times a squared plus a squared times a plus a squared times a. And if we substitute y equals 0 in, well, each of these three terms will also disappear, just like they did up here when we integrated with respect to z. So that means that this is equal to the integral from 0 to a of 2x times a, or a squared, plus a squared times a, which is a cubed, plus a squared times a, which is another a cubed. And we want to integrate with respect to x this time. So let's go ahead and let's integrate with respect to x. So integrating with respect to x, we'll have x squared times a squared plus x times a cubed, or a cubed times x, and then another a cubed times x. You could combine these two at this stage. I'm just going to combine them as we finish. So this will be plus another a cubed times x, and we're going to evaluate this from x equals 0 to x equals a. So substituting in x equals a, we're going to have an a squared times an a squared, so an a to the fourth, plus an a cubed times a, so another a to the fourth, and finally plus another a cubed times a, which is another a to the fourth. And if we substitute x equals 0, we see that each of these three terms are 0. So what we're left with is 3a to the fourth. So this is our surface integral. Now, we also know that this right here is the flux given by F through the surface N. So we can also say that our flux is equal to 3a to the fourth. And we know that because the surface integral that we found was also equal to 3a to the fourth. Now, the next step of this problem is to go ahead and use a computer algebra system to verify the solution. Thank you.